Your Moodle site is installed and the dashboard is working. But some of the most important parts of the platform are still fast asleep. Without cron, scheduled tasks, queued jobs, cleanup operations, and form notifications will not run properly. And without email, password recovery, and user notifications simply go nowhere. So in this video, we are going to wake up Moodle's background engine, and then prove step by step that it actually works. We will configure cron, inspect its tasks, install Mailpit for safe email testing, and finish by sending a real password recovery email and a cron-dependent form notification. Welcome back to Open Education Operations. This is part of the Moodle 5.2 post-install series. Grab a coffee, open a terminal, and let's get into it. Rule number 1 when working on servers: never assume, verify. Before we touch cron or email, let's confirm that we are exactly where we think we are. First, let's ask Moodle about its version directly through its command line configuration tool. This runs Moodle's configuration script as www-data, the same operating system account used by Apache. The result confirms that this server is running Moodle 5.2.1. Next, I will locate the PHP command line binary that cron will use. On this server, PHP is located at ucr/bin/php. Now I will check its version using this command. This step matters because the PHP version used in the terminal can be different from the version loaded by the web server. Our CLI is using PHP 8.3, which is exactly what we expect from this installation. Finally, I will confirm the web server account exists. Now we need to confirm that Moodle's cron script exists in the expected location using this command. The result shows that the file is present, so the path is correct. One final permissions check. Verify that the www-data user can read Moodle's config.php file. We got another successful result, which confirms that the web server account has the access it needs. So the environment checks out. Write Moodle, write PHP, write user, write paths. With the stage set, let's meet the crow that works behind it and run them by hand before we ask the server to do it for us. Before automating anything, we should run cron ourselves. This is an important troubleshooting principle. First, prove that the command works manually, and only then ask the server to run it automatically forever. So what exactly are we running? Think of Moodle cron as the backstage crow keeping everything running behind the scenes. Users might never see it directly, but while everyone else is looking at the course page, cron is behind the curtain sending messages, cleaning temporary data, processing queues, and generally preventing the platform from becoming a digital store closet. So let's call the crow in. First, we will run Moodle cron as the www-data user using this command. Let's quickly break that down. sudo -u www-data runs the command as the Apache account instead of root. ucr/bin/php starts PHP in command line mode, and the final path points to Moodle's own cron script. The terminal now displays a sequence of scheduled tasks. On a recently installed site, this output can be fairly long. This is normal. Moodle has been waiting patiently for someone to finally let it do its chores. The process might take a little while, so I will speed up this part of the recording and come back when it finishes. The important result is that the process finishes without a fatal PHP error, a database failure, or a permissions problem. So Moodle's cron script clearly works when we launch it by hand. But we can't sit here typing it every minute for the rest of time. So the next question is whether Ubuntu itself has the scheduling service needed to launch it automatically. Moodle provides the PHP script, but Ubuntu still needs a scheduling service to launch it automatically. That service is also called cron, same word but different layer, and it's the part of the operating system that runs commands on a timer. I will check its status using system control. System control is the management command for systemd, Ubuntu's service manager. The important line here is this one. that tells us the cron daemon is already running. A daemon is simply a background process that runs without someone keeping a terminal window open. Cron is normally available on Ubuntu, but if it is missing from your server, I have included an optional installation script in the resources linked below. The script installs cron, enables it at startup, starts the service, and verifies that it is running. So now we are holding both halves of the puzzle, a Moodle cron command that works, and an Ubuntu cron service that's alive and listening. They just haven't been introduced to each other yet. Let's connect them. To achieve this, I will create a dedicated cron configuration file for Moodle. I like this approach because it keeps the Moodle job separate and easy to inspect, instead of hiding it inside a user personal cron tab. We will give it a clearly named file under etc/cron.d. This command writes the entire configuration directly into etc/cron.d/Moodle. At the top, we define the shell and the executable search path. That gives cron a predictable environment instead of assuming it will inherit the same environment as my interactive terminal. The 5 asterisks, believe it or not, mean the command runs every minute. After the schedule, www-data tells the system which user should execute the command. That username is required here because files under /etc/cron.d are system cron files. Then we have the same PHP and Moodle cron command that we already tested manually. Finally, /dev/null discards the routine output. Without that redirect, cron could generate an impressive amount of noise every minute. Technically informative, but emotionally very exhausting. Writing the file is only half the job. Now we need to lock it down. I will start by assigning it to root. And I will apply standard read permissions using this command. This allows the system to read the file while preventing regular users from modifying the job. Now let's inspect exactly what was written using this command. The content matches what we expect. Great. Then we need to check its ownership, because, say it with me, verify, don't assume. As expected, the file is owned by root and has the correct permissions. There is no need to restart cron after changing this file. Ubuntu detects cron file changes automatically. Here is the satisfying part. I will now wait a few minutes so the scheduler had time to trigger the Moodle cron job several times. Then we will go straight to the logs and catch it in the act. Here we can see the Moodle cron command being launched every minute as the www-data user. This confirms that Ubuntu is detecting our cron file and running the job automatically. But seeing Ubuntu launch the command is only the operating system half of the story. It tells us the trigger is firing, not whether Moodle is actually getting its work done. So let's cross over to the application side where Moodle shows us the real tasks, their schedules, and whether they are succeeding. We can leave the terminal for a moment and verify what Moodle sees. I'm back on the administrator dashboard. From here, I will click on Site Administration. In the Administration menu, I will select Server and then click on Scheduled Tasks under the Tasks section. This page is essentially Moodle's background work calendar. Each row represents a recurring task. Some tasks process forums, others clean logs, remove expired data, perform update checks, generate analytics, or prepare automated backups. The exact list depends on the Moodle version and the plugins installed on the site. Let's focus on the columns that are most useful to an administrator. Last run tells us when Moodle most recently executed the task. Next run tells us when Moodle expects to execute it again. Fail delay shows whether Moodle is postponing a task after a failure. A non-zero fail delay deserves attention. It means Moodle attempted the task, encountered a problem, and scheduled another attempt later. The logs column gives us the task's execution history and more detail when we need to troubleshoot it. You may also notice different row colors. A task can be highlighted when its schedule has been changed from the plugin default. A task displayed in red is a more serious warning that it has repeatedly failed. And here is the payoff from the last step. Those updated last run values are our application level proof that cron is not just starting, it's actually processing Moodle's work. Now, you prefer the terminal? Moodle's got you. This command lists every scheduled task right in the shell. This produces a list of scheduled task class names, their schedules, and their next expected execution times. The class names may look slightly intimidating, but we don't need to memorize them. They are simply the exact technical identifiers Moodle uses for its tasks. When troubleshooting one particular task, we can execute only that task immediately. The general command looks like this. This is useful when one task is failing and we want to see its output directly instead of waiting for its next scheduled run. For this video, our normal cron execution is healthy, so there is no reason to force every task manually. That would be less system administration and more pressing every button to see what happens. Scheduled tasks cover the work Moodle does on a repeating timer. But there is a second kind of background jobs, the one-off do-it-once variety, and it lives right next door. Let's stay in the same tasks section and look at ad hoc tasks. We are still inside site administration under server and tasks. This time I will click ad hoc tasks. Ad hoc tasks are different from scheduled tasks. Scheduled tasks repeat according to a defined schedule. Ad hoc tasks are temporary, one-time jobs that Moodle creates when something needs to be processed in the background. For example, a plugin might queue an asynchronous operation, or Moodle might postpone a larger action so that the user does not have to keep staring at a loading screen. On a new or lightly used Moodle site, this page may be empty. This is not an error. It simply means there is no temporary work waiting in the queue at this moment. We can also ask Moodle to process all currently queued ad hoc tasks from the terminal using this command. If tasks are waiting, Moodle processes them and prints the details. If the queue is empty, like in our example, the command finishes quickly. Under normal operation, cron handles these tasks automatically. This command is mainly useful during testing or troubleshooting. So that's the full picture of Moodle's background workload. Recurring scheduled tasks and temporary ad hoc tasks, visible from both the dashboard and the shell. Before we close the book on cron and move over to email, there is one small security setting that's worth 30 seconds of our time. From the administrator dashboard, I will open Site Administration and then open Site Security Settings. This page contains a long list of settings, so rather than scrolling and hoping for the best, I will use the settings search and look for the word cron. The setting we want is cron execution via command line only. This setting prevents visitor from triggering Moodle cron through the web address like I am testing now. Our server already runs cron through PHP CLI, which is the recommended approach, so browser-based execution is unnecessary. The setting is enabled here, which is what we want. On current Moodle installations, command line only cron is generally the expected configuration. I am showing it so that we verify the protection rather than simply assume it is present. This is only one small hardening check. HTTPS, firewall rules, update strategy, backups, and the rest of the production security work deserve their own video. And that's a wrap on the background processing side. Cron is configured, verified, and logged to the command line. Now let's switch our attention to the thing your users notice the very second it stops working: email. Moodle relies on email for much more than a simple welcome message. Password recovery, forum subscriptions, assignment feedback, account notifications, and many plugin workflows can all generate outgoing mail. Technically, Moodle creates those messages and hands them to an SMTP server. In production, that SMTP server would normally be a real mail service or relay. We would use a verified domain, authenticated credentials, transport encryption such as TLS, and sender domain controls such as SPF, DKIM, and DMARC. We would also care about delivery failures, rate limits, bounced messages, spam filtering, and the reputation of the sending domain. But this server is not at that stage yet. We are validating Moodle's configuration and behavior before introducing a public domain and a real mail provider. Connecting this lab directly to a production mail service would create several unnecessary risks. This is why we are using Mailpit. Mailpit acts as a local SMTP server and a web-based inbox. Moodle sends messages to it using the normal SMTP process. But Mailpit captures those messages instead of delivering them to the public internet. For a Moodle administrator, this is extremely useful. We can verify that Moodle generated the message, used the expected sender and recipient, produced both HTML and plain text content, included the correct links, and handed the message successfully to an SMTP server. We can also test cron-dependent workflows repeatedly without filling real inboxes or accidentally sending 17 password reset emails to someone who never volunteered for this experiment. So this approach is a good fit for personal labs, for local development environments, demonstration servers, or also controlled development or staging environments. On a shared development or staging server, the Mailpit interface should still be protected. Access can be limited with firewall rules, a private network, authentication, tailless, or a loopback-only band. Mailpit is not our production email solution, and this test does not prove public email deliverability. It proves the application side of the chain. Moodle can generate a message and transfer it to an SMTP server. When this series reaches the production domain and deployment stage, we will replace Mailpit with a real SMTP provider and cover the settings that matter there. For this lab, Mailpit gives us exactly what we need: a controlled, visible, and repeatable email testing environment. Enough theory. With that distinction clear, let's get it installed. We will install Mailpit using the installer provided by the official project. This command downloads the official installation script and runs it with administrator privileges. Because it executes a remotely downloaded script as root, this is something we should only do from a source we trust. For this controlled lab, we are using the project's documented installer. In a structured production workflow, an administrator may instead pin a specific release, download the binary separately, and verify the checksum before installing it. Once the installation finishes, the Mailpit binary should be available under usr/local/bin. And because we never assume, let's confirm that before moving on. The file is present. Great. Now I will ask Mailpit to display its installed version. So the application itself is installed. But an installed binary is not the same as a running service. The next decision is how Mailpit should run. And we definitely don't want to launch it by hand as root every time the VM reboots. So let's give it a proper lockdown home of its own, starting with a dedicated service account. I will create a system account named Mailpit using this command. This is not a normal user account intended for someone to log into. -- system creates an account for a server. -- no create home avoids creating an unnecessary home directory. And UCR/sbin/no login prevents interactive shell access through this account. This follows the principle of least privilege. The Mailpit process receives only the access it needs to perform its job. Now I will verify that the account exists. The account is ready. Mailpit also needs a persistent location for its local database, so I will create that next. Despite its name, the install command here is not installing another application. It creates the directory and assigns its owner and group in one operation. Now let's verify the result. Good, the directory belongs to the Mailpit user and group. That means Mailpit can write its database there without needing to run as root. So now we have got 3 ingredients sitting on the counter: the application, the service account, and the storage directory. The last piece is the receipt that ties them together. A systemd service that runs the right binary as the right user right into the right place. So let's create a systemd service unit. This will allow Mailpit to start automatically with Ubuntu, restart after a failure, run under its dedicated account, and be managed using the same system control commands as other system services. Let's look at the important parts without disappearing into every systemd detail. Exec start defines the command that launches Mailpit. The -d option points Mailpit to the persistent database under var lib Mailpit. Restart asks systemd to restart the service if it stops. Restart seconds waits 10 seconds before the restart, which prevents an aggressive loop if the service has a configuration problem. User and group make sure Mailpit runs under the restricted service account we just created. And wanted by allows the service to start as part of Ubuntu's normal boot process. Before loading the service, I will review the file we just created. Everything matches the configuration we intended. Great. With the unit file written and double-checked, we can hand it to systemd and bring Mailpit to life. Whenever we add or modify a systemd unit file, the first step is to reload systemd's configuration. So let's do it using this command. Next, I will enable Mailpit so it starts automatically during future boots. Enabling a service configures its startup behavior, but it does not necessarily launch the service right now. So I will start it separately using this command, and now I will check its status. I mean the status of Mailpit, not Mailpit. Now that confirms systemd successfully launched Mailpit under the dedicated service account. For another view of what happened during startup, I will inspect the recent service logs using this command. The logs show that Mailpit started its SMTP listener and its web interface. Great. Logs are reassuring, but let's get hard evidence and check the listening ports directly. Port 1025 is Mailpit's SMTP listener. That is where Moodle will send its messages. Port 8025 hosts Mailpit's web interface. That is where we will inspect the captured messages. By default, this simple configuration makes those services available on the VM's network interfaces. So let's see the inbox for ourselves. I will open the web interface in the browser on port 8025. The Mailpit inbox is open, and it is currently empty. An empty inbox is exactly what we want to see right now. The catcher is in place and waiting. Time to step up to the plate. Let's go back to Moodle and point it at the SMTP destination we just built. I'm back on the Moodle administrator dashboard. I will click Site Administration and then click Outgoing Mail Configuration under Email. This page contains the settings Moodle uses when it hands outgoing messages to an SMTP server. I will start in the SMTP section with the SMTP hosts field. I will put here the loopback address. It always refers to the current machine. Because Moodle and Mailpit are running on the same VM, Moodle can connect to Mailpit locally without sending traffic to another server. Port 1025 is the SMTP port we verified a moment ago. For now, I will leave the remaining options at their default value or leave them blank. Now I will scroll to the no reply address field and enter this email. The .test domain is reserved for testing and documentation, so it's appropriate for this isolated environment. I will leave allowed email domains empty. With this lab configuration, Moodle can use the no reply address consistently rather than attempting to send from individual users' addresses. These settings, and I mean no encryption, no authentication, and .test sender, are correct only because Moodle and Mailpit are communicating inside this controlled lab. They are not production SMTP settings. Now I will scroll to the bottom of the page and click Save Changes. Moodle accepts the configuration without displaying an error. That confirms the form is valid. But a saved form only proves Moodle accepted the settings, not that it can actually reach Mailpit. There is only one way to know for sure, and that's to send something. I'm on the same outgoing mail configuration page. I will scroll down to the Test Outgoing Mail Configuration section and open the test tool. I will enter the local test address and send a test message. Moodle reports that the message was sent successfully. I will switch back to the Mailpit browser tab and see whether the message actually landed. And here it is, our first captured Moodle email. We can inspect the recipient, sender, subject, HTML version, plaintext version, and headers also. At this point, we have confirmed the basic technical path. Moodle, SMTP connection, Mailpit, captured message. This is what we want. That proves Moodle can reach the SMTP server and transfer a message successfully. But this built-in test is still just a diagnostic button. It's Moodle's talking about itself. To really trust the setup, we want to see email triggered by a normal Moodle workflow. So let's bring a test account I prepared before recording and put the system through its paces. To keep this video focused on platform configuration, I am not going to stop here and demonstrate how to create a user. User and profile management, course creation, and enrollment are standard Moodle operations that we will cover properly in separate videos. For today's tests, I already created a user named teststudent with the following email address. Let me quickly show you that account so we know exactly which user will receive the messages. Now I will open the site administration, click on users, open accounts, and select browse list of users. Here we can see the account and confirm that its email address is student@openeducationoperations.test. That's all we need from the user management side. Now let's step out of the admin chair entirely and experience this the way a real user would. Starting with the single most common reason anyone ever triggers a Moodle email, forgetting a password. I will open it on a new private window in Firefox. On the login page, I will click the password recovery link labeled Forgot Password. Moodle allows us to search by username or by email address. I will use the email option, enter the email, and click search. Moodle now displays a generic confirmation message. Notice that it does not openly tell us whether the address belongs to an existing account. That helps reduce account enumeration where someone repeatedly tests usernames or email addresses to discover registered users. Now let's return to Mailpit. And a password recovery email has appeared. I will open it and verify the recipient is the test student, the Moodle site name is correct, the sender information is correct, and the message contains the password reset link. This test is stronger than the diagnostic message because it proves that a real Moodle workflow can generate a user-specific email. But notice something. Password recovery happens the instant you click the button. It does not need cron at all. And cron was the whole first half of this video, so we can't finish without closing that loop. So for our grand finale, let's trigger an email that can only arrive if cron is doing its job, a form notification processed in the background. For this last demonstration, I prepared one more piece of test data in advance. I already created a small course, enrolled test student, and add a forum named notification test. What matters for this test is that the student is enrolled and the form uses forced subscription. This ensures that all enrolled users are subscribed to this forum, so our test student is eligible to receive notifications when a new discussion is posted. Let's return to the forum and create a new discussion topic. I will enter a subject and a short test message. Next to the posting controls, we need to click on Advanced to reveal the additional options. Here, I will enable send forum post notifications with no editing time delay. Normally, Moodle gives an author time to edit a forum post before distributing the notification. For this control test, we want the message queued immediately, so we are intentionally skipping that delay. I will now click Post to Forum and move directly to the terminal. Cron begins processing Moodle scheduled and queued works. Because our automated cron job already runs every minute, it is possible that Ubuntu will process the message before I launch this command manually. That is not a problem. In fact, it would confirm that the automatic schedule is doing its job before I can dramatically demonstrate it. Once cron finishes, I will return to Mailpit one last time. And here it is. We have now verified the complete workflow. Forum post, Moodle background task, cron, SMTP, Mailpit. We have demonstrated that Moodle can create background work, that cron can process it, and that the resulting email can reach the configured SMTP server. And with that, two halves of this video have finally met in the middle. The cron engine we built at the start just delivered the email we configured at the end. Both parts of our post-installation setup are working together. Let's quickly recap what we achieved. Our Moodle installation now has a working background processing system and a fully tested local email path. Cron runs automatically every minute as the correct web server user. We can inspect scheduled and ad hoc tasks from both Moodle and the terminal. We tested 3 different email scenarios: Moodle's diagnostic message, a password recovery email, and a cron-dependent forum notification. That gives us confidence that Moodle can generate messages, process background work, and transfer email successfully to an SMTP server. For now, our local Moodle environment has moved from technically installed to actually doing its job. If this video helped you, subscribe to Open Education Operations and drop a comment telling me what you would like to see configured next. Thanks for watching, and I will see you in the next one.